Hi, thanks for joining me in this video on digital pressure transducers. A digital pressure transducer makes use of a diaphragm. This is a little flexible piece of material that deflects as pressure changes. And as a result, you can get different types of responses depending upon how this instrument is designed. Either you'll get an electrical change that's related to the piezoelectric effect, or there might be a change in capacitance, or maybe even inductance through an electromagnetic type effect. What we mean by piezoelectric is that the crystals and certain ceramics, as they deform or as they are stressed, there's some sort of mechanical stress, there will be a voltage generated if there is a charge that is applied to the material. Here's a cross-section of what a piezoelectric foil looks like, or a piezoelectric surface. When you put a current running through this, when you have a current running through, you'll get a change in either a capacitance or resistance related to the strain or deformation that's applied to the substance. Typical piezoelectric substances are made of ceramics. There's a PZT type ceramic that has very good sensitivity, but over a period of time it tends to degrade. But most piezoelectric sensors are typically made of single crystal materials like silicon, quartz, because they have better long-term stability. Another type of diaphragm is a capacitive sensor. And what this means is that you have a silicon membrane that is layered over a evacuated chamber, a vacuum, that's inside the sensor. And as pressure changes, you get deformations in the membrane. It flexes up and or down. And as a result, if you put two charged plates, one on top of the electrode or the base, and the other one on the bottom of the membrane, as the distance between the membrane and the base of the sensor increases or decreases, you get changes in capacitance if these two plates are charged. So the change in capacitance is directly related to the change in pressure. Another type of diaphragm is one that uses an electromagnetic sensor. So once again, you have a diaphragm and evacuated chamber, and very much like the capacitance type device or the capacitance type sensor, as the membrane flexes, you get changes, but instead of getting changes in capacitance, you get changes in inductance. So it uses a slightly different electrical property. For these diaphragms and these sensors to work properly, you need to have a reference pressure. Typically, that is a vacuum. In other words, the chamber is evacuated and the membrane is able to flex, but it's rugged enough where it doesn't totally collapse into the sensor. These sensors are also very rugged. I've read some literature where it says you can drop one of these sensors from 8 feet and it still works. These sensors also are typically built right into integrated circuits, so the information or the signal that comes out from them is digitized and stored on a computer. The characteristics of these digital pressure transducers is that they have very low mechanical hysteresis, they're fast, and they have a very dynamic response, and they can be temperature compensated also. The types of pressure that is measured by these digital pressure transducers are absolute, meaning either station or atmospheric pressure, or can be used for differential pressure, such as a pitot tube measuring airspeed. Here's a standard that's used on all ASOS and AWOS machines. It's a digital pressure transducer made by a company called Setra, which is located in Massachusetts. The standard is the model 470. Also on AWOS, most AWOS stations, The pressure standard is the Vizsla PTB 330, which is a capacitance type device. And this is, of course, the most reliable sensor on ASOS or AWOS systems. With an ASOS, there are 3 pressure transducers that are located on the inside of a rack that is located inside a building. They don't put these pressure transducers outside in the elements. They keep them inside. There are static lines that go to the outside of the building so that you can measure true atmospheric pressure. And the reason you have 3 sensors is that if one starts to drift and go out of calibration, the other 2 should have the accurate measurement, so you can tell which instrument is bad. And did they do quality assurance with ASOS algorithms? If the sensor is off by more than 4/100ths of an inch of mercury, then a flag goes off. In the METAR, you'll see a $sign at the end telling you that the sensor is bad and it needs to be either replaced or recalibrated. Also, there are portable standards that can be brought in to recalibrate the instrument. That's a little bit of information for you about digital pressure transducers.